Hi, hello everyone. I will present to you model-based analysis to evaluate the effect of polymer properties and physical phenomena on polymer fluid operations. This work was performed by me, Bruno, Susana Santos, and Professor Denis Schiozer. The polymer fluiding presents several physical phenomena that are absent in the water fluiding process. Here we can highlight the non-Newtonian behavior, the rock-fluid interaction by the retention and adsorption phenomena, injectivity loss, and also the rheological impairment due to the harsh conditions in the reservoir, such as salinity and temperature. All these issues related to this EOR method becomes the motivation of this work. About the objective, this work aims to evaluate the importance and impacts of the viscosity, shear height, absorption, and injectivity loss on the polymer fluiding prediction forecast. For this purpose, the methodology applied here is summarizing this flow chart. So we start with the polymer fluiding parameters and the assumption, where is defined the water phase, salinity, rheological data under interest condition, the target viscosity and polymer concentration to be injected, and also the rock fluid parameters. Here we work with the modeling approach. The first one represents just the viscosity effect, called as ideal approach. So we work with nonlinear viscosity function, considering the apparent viscosity and zero shear viscosity, which the fluid represents like a Newtonian behavior. The second one was the shear height effect that was modeling with shear thinning logarithmic model. And the last one was the adsorption effect that was modeling with or without shear height effect. Here in this graphic, we can observe the apparent viscosity for each polymer concentration. The target viscosity was 20 cp that was reached by this polymer concentration. As we don't have the flow curve of this polymer concentration, we estimate the values according to the Carroll parameters of these two flow curves here. And here we present the adsorption function that was obtained from the literature data. Here we have the simulation results associated to the reservoir's indicators, injectivity, and the net present values. This last one, it was calculated according to the taxes, market values, and the injection and production costs. About the application and the prediction strategies, here I will present some assumptions. This image presents the 2D view of top reservoir, where we can observe the well placement. So we have 3 injectors placed near to the reservoir bottle, and also 4 producers placed in the middle of the model. In this timeline here, we can observe the strategies that was applied. It was assumed the water fluiding has already implemented in the model, so the polymer fluiding should be started as a tertiary mode. For both strategies, it was started with natural depletion, followed with water fluiding, and then the polymer injection start in this date. The injection rate for both strategies was this value for each injector well, and the polymer concentration was the target one. Now we present some results. In this graphic, I present the reservoir pressure and here the injectivity. When the polymer fluid starts, we can observe a reduction in the reservoir pressure here. The inclusion of the shear height effect tends to reduce the drop of the reservoir pressure, and the adsorption approach present the lower values of the pressure maintenance. About the injectivity, we can observe here that the polymer, when the polymer injection starts, the injectivity is reduced, and among the effects, the shear heating tends to increase the injectivity compared to the other ones, and the adsorption approach presents the lower values of this indicator. About the oil production, here we have the production rate and here the recovery factor. In this graph we can observe when the polymer injection starts, the oil production was delayed for all approaches. Also we can observe the adsorption effect promoted the high delay and also the lower oil production rate. Considering the absorption approaches, the oil reduction was around 6, 8, and 7% when compared to the ideal and shear height approaches, respectively. This impairment in the oil displacement can be associated to the polymer propagation delay in the porous media, associated to the adsorption phenomena. This effect we can observe here by the polymer breakthrough date. When we consider the adsorption approach, the delay was around 56 months compared to the other ones. Even though here we can observe with the polymer approaches increase the recovery factor compared to the water fluid. Here I represent the net present values that was normalized by water fluid in case data and also the simulation time for all approaches. Observe here, without adsorption effect, the NPV was increased when considering the shear height effect. The economic return was 3.2 and 1.3 higher than those presented by ideal approaches observed here. However, modeling the shear height effect, the elapsed time of simulation increased more than 38 times. Considering the adsorption effect, when the shear height was modeled together with this effect, the NPV was not affected. Also, we can observe that at maximum adsorption level, we obtained the lower economic return of this method. Reducing the adsorption levels, the NPV increased for all approaches here, and the economic return started to be higher than water fluid when the adsorption values was reduced by 25%. But here we have an exception. Some conclusions and remark of this work. The polymer fluiding provides better sweep efficiency and higher recovery factor than water fluiding process. The EOR method efficiency was dependent on the solution viscosity injected and also by its biological behavior during the flow process. The rock-fluid interaction by adsorption phenomena reduced the polymer fluid effectiveness, which affected the economic return. To further polymer fluid optimization, the absorption value should be considered as uncertainty, and as the shear height effect presents a feasible simulation time to perform the optimization process, the effect modeled by the approach considering the adsorption and apparent viscosity could be considered for this purpose due to its intrinsic value of shear height in the viscosity values and by the similar NPV values to the approach modeled with adsorption and shear height effect. Some reference used here. And finally, I would like to thank all sponsors involved in this project. And thank you so much for your attention.